Hi everyone, this video will introduce the concept of biodiversity and how we can measure it. You may want to make notes and we will be doing calculations, so you will need a pen, paper and calculator to hand. So what is biodiversity? Well, it is the amount of variety of life in a particular habitat. It refers to the number of living organisms in a particular area and it has three components: species diversity, genetic diversity, and ecosystem diversity. This video is going to focus on species diversity and how to measure it. The learning objectives of this video are to be able to explain what is meant by these terms: species richness, biodiversity, and the index of diversity. We are also going to be able to calculate the index of diversity and draw conclusions from it. One way to do this is by measuring species richness, which is simply a count of the number of different species represented in an ecological community. But this does not take into account the individuals present from each species and proportion. For example, the data in this table does not tell us much about the differences between habitat X and Y, as both the number of species and number of total individuals are the same, although it is clear to see a difference in diversity between them. In order to measure species diversity, we need to calculate the index of diversity. We do this using the following equation, and we will calculate an index of diversity for each habitat separately. The easiest way to start is by adding extra columns to our table of data. N equals the total number of individuals of each species, and we have this data already. So we create a column for this part of the equation, N multiplied by N minus 1. So for species A in habitat X, we would multiply 10 by 10 minus 1, which is 9, inside the brackets and outside of the brackets to get 90. For species A in habitat Y, we multiply 3 by 3 minus 1, which is 2, to get 6, and so on. The equation asks for the sum of n minus 2, therefore we must add up this column for each habitat. This gives us the first bottom part of our equation. For the top part of our equation, we need to calculate capital N, which is the total number of all individuals across all species. We do this by finding the sum of the N column. So for habitat X, this is 10 plus 10 plus 10 plus 10 plus 10, which equals 50. And for habitat Y, this is 3 plus 5 plus 2 plus 36 plus 4, which also equals 50. The equation asks for capital N multiplied by capital N minus 1. Therefore, habitat X is 50 multiplied by 49, which gives us 2,450. And habitat Y is also the same in this case. Now we can complete the equation for each habitat. For X, we just add our values into the equation. We end up with 5.44 as our index of diversity. For habitat Y, once we've inputted our figures into the equation, we end up with 1.88. The higher the value of D, the greater the species diversity. The benefit of calculating index diversity is that it takes into account the number of individuals present within each species. This is important as some species may be present in small numbers compared to others. Now it's over to you. A construction firm has the choice of two plots of land to build on, Habitat A or Habitat B. They want to choose the plot with the least biodiversity, as to cause less damage to the local ecosystem. Have a go at calculating the index of diversity for Habitat A and B and find out which habitat the construction firm should choose to build on. Pause the video and we will go through the answers on the next slide. How did you do? Here are the calculations. Compare your answers and if you got something different, check the working out. Bring this with you next lesson for me to see. So that's the end of our video. We've covered all of our objectives. Next lesson, we will be practicing more exam questions and I'll be able to give you one-to-one support if you have had any problems.